Integrated 2, Chapter 6, Day 7. Getting close to the end of this chapter. So, this fractional exponent stuff, I think is pretty easy if you let it be, but kids really seem to struggle quite a bit with it. The idea of fractional exponents is this, that we get something that would be, let's say we had 49 to the half power. Well, this number here tells us that we need a number that multiplies by itself 2 times that equals 49. So this is the number of times a number multiplies to itself. And then the top one, and that says that we have one of them. So this is how many of them we have. So what does that mean? Well, when I look at 49 to the half, I need a number that multiplies to itself 2 times. So what number times itself twice equals 49? And of course that number is 7, right? 7 times 7 is 49. And I have one of them. So 49 to the 1/2 power equals 7. Or if you think about it, it's like a square root, right? Well, what if I had something that was like 8 to the 4/3? Again, what we're saying is start with the bottom number. I need a number. This is the number of times that a number multiplies by itself. So what number multiplies by itself 3 times to give us 8? Well, 1 times 1 times 1 equals 1, so it's not that one. What about 2 times 2 times 2? 2 times 2 is 4, 4 times 2 is 8. So that number's 2, right? And I have 4 of them. This is how many of them I have. So 2 to the 4th power is 2, 4, 8, 16. So 8 to the 4/3 power equals 16. And 49 to the 1/2 power equals 7. And again, the bottom number is the number of times a number multiplies to this number. And the top number is how many of those numbers that you have. Excuse me for 1 second, I'll pause. I was kind of ignoring some of the notation on these, which is fine, and we're going to get into the notation later. But essentially, for any real number a that has the integers n and m, so we'll say m to the nth power, really what we're saying is that we have the nth root, the number on bottom, m times. That's really what we're saying. So what we're saying here is 16 to the half is we have the square root of 16 one time. I still like to think about it as the bottom number. So what number times itself equals 16? 4 does. And I have 1 4. Right? Here, 27 to the 3rd power. So the 3 is going to go here. There's one of these things, right? So it's the cube root of 27. So, and again, if you think about it, what number times itself 3 times equals 27? Well, 3 does. 3, 9, 27. And we have one of them. So here, this one's a little bit trickier. So what number times itself 3 times equals negative 8? Well, it's negative 2, right? Negative 2 times negative 2 is positive 4. And positive 4 times negative 2 is negative 8. And we have 1 negative 2. And then finally here we're saying the 4th root of 16 to the 1st power. And again, these are all assumed ones. They don't have to put a 1 here. If it was like a 2, they would need to put a 2. But if it's an assumed one, you don't have to put it. So in this one, we're saying what number times itself 4 times equals 16? It's obviously 2. 2, 4, 8, 16. And we have 1, 2. So there we go. So it's pretty simple when we get something that looks like this. Again, we're going to take the base to the 1/2. Essentially, this means, if we want to write this in radical notation, that we want the square root of x, and we have one of them. Now, a lot of people don't like the way this looks. They prefer to write it like this. And that's fine. They both have the same value. Again, if I say x, it's assumed to be 1x. If I just put a square root, it's assumed to be 2. If it's a 3 or a 4, I have to put the 3 or the 4. So this means there's 2 here and 1 here. But if you want to write that, you can. But on this one, what we're saying is you have to put the 3 and the 2. Because if you don't put anything, this is assumed to be a 2 and this is assumed to be a 1. but here you have to put a 3 and a 2. And then here, same thing. We're going to say it's the 4th root of x, and you have 3 of those roots. Again, what number times itself 4 times equals x, and then you have 3 of that number. So if we go ahead and rewrite this one, we're going to say it is the nth root of a, and we have m of them. And on this one, don't forget this one is going to be fractional, right? So this is the same as 1 over m, 1 over a times n to the n. Hopefully you guys remember negative exponents move across the fraction and turn positive. So we're just going to say it's 1 over the n a m right there. So let me pause again real quickly. Excuse me, I apologize, there's a lot going on. So anyway, so we have our rules and how they look, and we have some examples. And now let's go ahead and do some of these things. And again, I don't think it's as bad as it looks. So this says that I need the square root of 100, and I have one of them. So what number times itself twice equals 100? That number is obviously 10, right? On this one, what number times itself 4 times equals 16, and I have one of them? So that number is 2, right? 2, 4, 8, 16, 2 to the 4th power, and I have one of them. So these ones are all pretty simple. There's nothing really too crazy going on here, I think. So like on this one, we'll say I want the cube root of 1,000, and I have one of them. So again, what number times itself 3 times equals 1,000? I think it's 10. 10 times 10 is 100, times 10 is 1,000, and I have one of them. So my answer is going to be 10 here. So hopefully you guys can fill in the rest of this. I know it's a little bit kind of interesting, but you kind of get there eventually. So now we get into some, I think, trickier examples, and I like these ones a lot better. So first of all, this one is basically saying I want a number that multiplies to itself twice to give me 100, and that number is going to be 10, and I have 3 10s. So if you think about that, again, I mean, I'll go through the notation of this, but I still just like to reason my way through this. So what I'm saying is, what number times itself equals 100? That number's 10, and I have 3 of them. So 10 times 10 is 100, times 10 is 1,000. That's what I'm going to get right there. So on this one, let's try this one. Now let's do this one. So this one, I want a number that multiplies by itself 4 times to give me 16. So if you think about that, that number is going to be 2, and I have 3 of them, right? So just this part of it, a number that multiplies, that's a 4 right there. A number that multiplies by itself 4 times 2 is 4, times 2 is 8, times 2 is 16. So that number is 2, but I have 3 of them. So my answer is 2, 4, 8. Anytime you see a negative exponent, it shouldn't be too crazy. I'll give you a little hint on this one. It's just going to be 1 over 121 to the half. So hopefully you can go ahead and finish that one off. Basically it's what we're doing over here, but you just have a 1 on top. So one more of these things. Again, I know that I want a number that multiplies by itself 5 times to give me 32. That number's 2, right? 2, 4, 8, 16, 32. And then I have 3 of them. So I am going to say it's the 5th root of 32, and I have 3 of them. The 5th root of 32 is 2, but again, I have 3 of them. So my answer is 2, 4, 8. So I hope that makes sense. A little bit tricky, but once you get the hang of it, I don't think it's too bad. You can definitely use a calculator if you get a little bit stuck on it.